Hey, I'm back. All right, so we're almost done. I have 2 chapters left, probably 3 lectures. I'm gonna try to keep them very short. I know you'll have a lot going on, and so do I. This is gonna be my first attempt to record a lecture while I'm in clinic. You know, I can't find another time to do it, and so that's why it's taking me so long to get these up. We're gonna get it done. So we're talking about the autonomic nervous system today, and I'm not going to say that this isn't interesting, but it is hard to understand. And so we're just going to skim right over the top, kind of bare bones our way through this. I'm going to give you what you need to know for the test. If you want to spend your life getting a PhD in, you know, the parasympathetic nervous system, well, good for you. If this lecture won't help you with that very much. All right. So we're going to first compare the difference between the somatic and the autonomic nervous system. Okay, we've talked about the somatic nervous system. That's the one that you are aware of, you control when you want to pick up something off the ground, and you know that happens at the volitional level. Okay, you think about it, you do it, it happens. That's not how the autonomic nervous system works. It's just like the sub-operating system of your brain. Stuff's happening, you have no idea. When somebody shines a light in your eye, you don't have to think, man, that's bright, I should probably make my pupils smaller. You don't do that. It just happens. And it gets a little tiny pinpoint, and then you take the light away and it expands again. Everybody's seen that, you know, they use it in movies for effect all the time. That's the autonomic nervous system in action. Okay, so you notice here we have the motor activity comes straight from the brain, down the spinal cord, and it comes to the anterior root, and it makes the muscle do what it wants. And then the sensory nervous system, we're talking somatics here, comes from, like here they're using the skin, but it doesn't matter, it could be any sensory information, comes up that same nerve, but then goes through the posterior root. Okay, that's how the somatic works. Well, for the autonomic nervous system, the efferent fibers, the ones that go from the brain to whatever the affected organ is, comes through the anterior root, and then the information, the visceral sensory information, again, because the visceral sensory information is part of your autonomic nervous system, goes back through the ganglia, through the posterior. So it follows a similar pathway in terms of the anterior and the posterior roots, but obviously what it does is different things, and it's a totally different set of nerves that goes there. Okay, so the hypothalamus, this is the command center for your autonomic nervous system. When I ask you on the test, look, I'm just handing it to you. Here it is, test question. When I ask what the command center for the brain, for your autonomic nervous system, in the brain for the autonomic nervous system is, the answer is hypothalamus. And you can remember that because it's right above your pituitary gland. Your pituitary gland is part of your endocrine system. That also happens, no volitional control at all. That's part of the what they call that old primitive part of your brain. It's not really primitive, they just think of it old evolutionarily, so that's why they call it that. It's actually incredibly complex. So your brainstem, also this is major autonomic nervous system reflexes, so this is why even if you're unconscious, I conk you over the head, you're unconscious, you hit the ground, but you keep breathing. Why? Because of your brainstem, right? All those vital nuclei are in your brainstem. Remember, we learned those when we studied the brain. And then your spinal cord also has some autonomic nervous system reflexes that we're not going to get into a whole lot, but it becomes important, like for urination and release of fecal material, that kind of thing. All right. This is that autonomic reflex. We are just not going to get into that. Okay. So the difference, there are 2 big parts to your autonomic nervous system. Okay, this is the efferent part, right? The part that goes out. So you have your parasympathetic division and your sympathetic division. Listen closely, this is very important. There's going to be at least 2 questions on the test about this. So your parasympathetic portion, this is your rest and digest, okay? Your sympathetic nervous system is fight or flight. So when you get ready to fight for your life, or, you know, even if it's something stupid, you just get angry, you get all worked up, road rage or whatever, That's your sympathetic nervous system in full on, let's go. You just ate a big meal and you're kind of sleepy and you're just sitting around, then your parasympathetic nervous system takes over and does its thing. So they have a different origin. The sympathetic nervous system is here in this thoracic region. So look at your slides while I'm talking, because I know it's hard for you to see this screen. But you have what we call the sympathetic trunk, and this is from T1 to L2. That's the origin, from the peripheral nerves of your sympathetic nervous system. Obviously the origin's way up in the brain, but we're talking about its spinal origin. Now, your parasympathetic nervous system comes from a completely different place. It comes from these 4 cranial nerves, your oculomotor, facial, glossopharyngeal, and vagus, and then your splenic nerves, okay, your sacral. So they call the parasympathetic the cranial sacral division. So parasympathetic, cranial sacral, sympathetic, thoracic. Remember that. Okay. You have these ganglia that are in series, so to speak. They're connected for the sympathetic. You do not have that for the parasympathetic. Okay? Even though they have complementary sometimes and sometimes antagonistic effects, they do not directly affect each other. Okay, the sympathetic and the parasympathetic nervous system do not talk to each other. They both affect the organ, and they do what they're going to do to the organ, but they're not communicating straight with each other. Now, some things only have sympathetic innervation. They don't have any parasympathetic at all. So the adrenal medulla, your adrenal glands make your epinephrine, which is that surge that you feel when fight or flight. That's epinephrine. Your erector pili muscles, the one we talked about, stand up when you're cold or when you get emotionally wrought about something. Your sweat glands and most of your blood vessels just have sympathetic. So when the sympathetic nervous system works on them, they constrict, and then when it stops, they relax, but they don't have any parasympathetic innervation. So that's the list of things that only have sympathetic innervation. Okay, so we said the thoracolumbar division is the sympathetic, and they have those postgangliotic fibers after the paraganglionic vertebra, these ones in series here, what they call the sympathetic chain ganglia. All right, we are not going to get into that. All right. Next, okay, parasympathetic. So we have our cranial sacral division. We have our cranial nerves up here. You have your oculomotor nerve that affects the size of your pupil. So even though cranial nerve 3, that's your oculomotor, moves the eyeball around, which you do control, it also has some autonomic systems in it that change the size of your pupil. It also changes the size of your lens. We haven't gotten to vision yet, but we're about to. And that lens shape changes based on if you're looking at something far away or up close. So when I look at my watch, my pupil has to get tighter so that I can see up close, and then when I look away, it can relax. Now, as you get older, that thing gets stiffer and doesn't work as well, which is why I need these. I used to have very good vision, not so much anymore. All right, and then down at the bottom, your splenic nerves affect, your reproductive organs and the bottom of your colon. And again, that's the rest and digest stuff. Okay. So we already said they don't integrate, they don't talk to each other, they just talk to the affected organ. What about the neurotransmitters they use? Okay, preganglionic, they both use acetylcholine. That shouldn't surprise you, we've been talking about acetylcholine a lot. So acetylcholine, both the parasympathetic and the sympathetic use acetylcholine. But postganglionic, the parasympathetic still uses acetylcholine, the sympathetic uses norepinephrine. You ought to be able to remember that because epinephrine and adrenaline is the same thing. So your fight or flight system uses norepinephrine, postganglionic. Okay, they both use acetylcholine preganglionic. So this is the big overview slide. If you know this slide, you're going to be in very good shape. Notice we have our sympathetic nervous system here, acetylcholine here, norepinephrine here. So this is the ganglion. Okay. Here, parasympathetic uses acetylcholine, both spots. Parasympathetic, your cranial nerves control all this stuff. Parasympathetic innervation of all these things here. And then you're down here, your sacral nerves affect the bladder, your reproductive glands, and the bottom of the colon. Okay, your thoracolumbar system does your sympathetics, and it has sympathetic effect on all these things that we talked about. Okay, that is all that you really need to know for the autonomic nervous system. Go ahead, learn these facts, especially the ones that are really emphasized. And let me turn this off. I'm in the middle of the lecture, hold on. And that'll be it. I'll do my next lecture lickety split and upload it too.